Hello and welcome back to the channel, everyone. Thank you so much for your support. Today we're going to be walking through a molar ratio question, typically found both in GCSE chemistry as well as A-level and advanced placement chemistry. So molar ratio means the proportion of one reactant to another reactant or product in a chemical equation. And then once you know that ratio, you can work out what is asked for in the question, whether that's a mass of a product, a volume, or a concentration. So today we're going to be walking through a typical question that I've taken from a past paper using the molar formulas, so moles for solids, liquids, and gases. So let's take a look. So this video is a follow-up to the one that I did on reactive mass questions. If you haven't already watched that, please go back and see it. The link is below the description. Basically, I laid out a 3-point process to work out reactive mass questions, also known as molar ratio questions, which you can use for every single one of these questions you come across. In this example, you'll see that it involves reactants and products in the liquid and gas phase, which is different to the one that I covered previously. So, however, I'm going to be using the same 3-point process just to prove that it can be used in any situation. So let's take a look at that again. So just going to scroll up and you can see this is what I went through, and it involves working out the moles of something you were given information on, then using the molar ratio between the thing that you want and the thing you have information on, and then finally turning that into a mass or a concentration or a volume or whatever is asked for in the question in point number 3. So again, go back and watch the video I did on this, as this process is described in detail. So I'm going to use this again today to do the question above, just to show you that it can be used even when we're not dealing with, a reacting mass in grams. It could be a reacting concentration. It could be a reacting volume. It's just the same thing over and over. So if I can get this on one screen here so you can see it. And I've attached this document again below this video, which I would advise you to print it out or save it somewhere so you can follow along. So let's get into it. So the first part of the question asks, what volume of carbon dioxide is formed when 2.16 grams of sodium carbonate dissolves in 25 centimeter cubed of phosphoric acid? And then part B, what concentration of phosphoric acid is needed for this reaction? So before we start the question, let's just lay out the formulas that we would be using. So for solids, the formula is moles equals mass over RFM. Then for liquids, solutions, is moles equals C times V. And then finally for gases, we have moles equals V over 24, where the volume in this case is in decimeter cubed, and the same for liquids. The volume must be in decimeter cubed, concentration in moles per dm cubed, and then the mass for this one in grams. So 3 states of matter, 3 formulas to work out the moles, and you just select the correct one depending on the question. So let's do part A. So what volume of carbon dioxide is formed when 2.16 grams of sodium carbonate dissolves in acid? So following the 3-point process, it says, step 1, look at the chemical equation and circle the 2 substances that are talked about in the question. So it talks about carbon dioxide, so I circle this. And it gives me information on sodium carbonate, which is this. So they're the 2 things circled. And then it says, work out the moles of substance B, the substance that you have information on, which in this case is the sodium carbonate. So step 1, moles. I'm given a mass of 2.16, so I'm going to be using the solids formula, moles equals mass over RFM. So I will be calculating this as I go along. So make sure you have your calculator. So 2.16 divided by the RFM of sodium carbonate, which is 2 times 23 plus 12 plus 3 times 16 is 48. So let's work this out. 2.16 divided by gives me 0.02037. Number 2, compare the molar ratio. So the molar ratio is 3:3, which is the same as 1:1. So therefore, the moles of CO2 is also 0.02037. So the moles is the same. And then finally, 3. Now that you have the moles of the substance, again, using the appropriate moles equation, work out what is asked for in the question. Well, the question is asking me to find the volume of carbon dioxide, and it wants it in centimeter cubed, not decimeter cubed. So that means when I get my answer at the end in decimeter cubed, I have to times it by 1,000, because there's 1,000 centimeter cubed in 1 decimeter cubed. So moles equals V over 24. V equals 0.02037 times 24 equals 0.489056 dm cubed. So timesing that by 1,000 gives me to 1 decimal place 489.1 centimeter cubed. Okay, so you can see in that first part of the question, I used the solids formula and the gas formula at the same time. Right, let's get on to part B. So for B, it wants us to find the concentration of phosphoric acid. So if I circle this in a different color now, use green, and I'm going to get rid of the circle for carbon dioxide because that is already been accounted for and we've worked it out. So I'm comparing the moles of sodium carbonate to phosphoric acid this time. Now we already worked out the moles of sodium carbonate in this step. So it's 0.023077. So number 1 has been done. So number 2, what is the molar ratio of sodium carbonate to phosphoric acid? And you can see that the molar ratio is 3:2. So if I want to work out the moles of phosphoric acid, I have to divide the moles of sodium carbonate by 3 and then times it by 2. So it'll be 0.020377 divided by 3 and times it by 2 gives me 0.01358 moles of H3PO4. Step 3. Now I can work out the concentration of the phosphoric acid. So I'm going to be using the liquids formula this time, liquid/solution. So moles equals CV. C equals moles divided by V. So the moles is 0.013584 divided by the volume. So the volume of phosphoric acid used in this question is 25, and that has to be turned into decimeter cubed. The reason why is because the concentration is always in moles per dm cubed, and the volume is given to us in centimeter cubed. So to convert, you divide 25 by 1,000, which gives 0.025. So dividing them through gives us a final answer of, to two decimal place, 0.54 moles per dm cubed. So there is an example of a question that has used all three formulas for working at the moles. Moles for solids, moles for liquids, and moles for gases. Thanks for watching. If you found this video helpful, please like and subscribe. And if you need any help, just comment down below. If not, I will see you in the next one.